Now we're going to find the exact value of sine of negative 13 pi over 6 and tangent of 13 pi over 6. Now you might say, negative 13 pi over 6 is not one of the angles in our unit circle that you asked us to memorize. Well, it turns out that it's what we call coterminal with another angle that we did talk about. Coterminal just means that the angles have all of the same trig function values, or that the terminal side ends in the same spot when you put the angle on the coordinate plane in standard position. So this is what I mean, right? If we think about splitting the coordinate plane, or I guess we should do the unit circle, into from 0 to pi into 6 pieces, right? That first angle will be pi over 6, right? Now what I'm going to do is I'm going to count by pi over 6. This is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Do you see what I'm doing? Okay? I could do that until I got to whatever angle I'm interested in, learning about the trig values. But it turns out that since I'm looking at, sorry my diagram's not very good. I'm trying to split it all into 6 pieces. It's not easy on the computer. I can count backwards. Yeah? So let's count backwards. This will be negative pi over 6, negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6, negative 5 pi over 6, negative 6 pi over 6, which is negative pi, negative 7 pi over 6, negative 8 pi over 6, negative 9 pi over 6, negative 10, negative 11, negative 12, negative 13 pi over 6. So I'm talking about an angle that's sitting right here that rotated all the way around. Oops, I'm sorry, that went too far. Wonder if I can get rid of that. Hold on, technical difficulties. Great. I'm talking about an angle that went all the way around and ended here, right? So this is negative 13 pi over 6, right? And what are the coordinates of its corresponding point? Well, we know that pi over 6 has coordinates square root of 3 over 2. Right, so if I put this here, this p would have square root of 3 over 2 comma 1/2. Since this version, or this multiple, I should say, of negative 13 pi over 6 is in quadrant 4, it's going to have a positive x but a negative y, right? Okay, so what that means then is if I'm going to look for the sine value of negative 13 pi over 6, remember sine is the y-coordinate, that will be negative 1/2. And then to find the tangent of negative 13 pi over 6, I have to remember that tangent is y over x. So I'm going to take negative 1/2 divided by the positive square root of 3 over 2. That's negative 1/2 times 2 over root 3, negative 1 over root 3, and rationalizing, I get negative root 3 over 3. All right, one last thing in this section. All the trig functions, in addition to being defined on the unit circle, can also be defined on circles of any radius. So we're going to now we're going to look at a circle that has radius r instead of radius 1. Okay? For an angle in standard position, theta, and for the point pxy that corresponds to theta on the circle, instead of x squared plus y squared equals 1, we're going to say x squared plus y squared equals r squared, which means it has a radius of r. Then we're going to define sine of theta to be y over r, cosine theta to be x over r. Tangent theta is still y over x, where x is not 0. We know r is not 0 because it's a radius. We have the cotangent of theta is x over y, where y is not 0. The cosecant of theta is defined as r over y instead of 1 over y. Stop it. Where y is not 0, and the secant of theta will be r over x, where x is not 0. Notice that these are actually identical to what we talked about before. It's just that the radius before was 1. So for instance, when we had sine theta equals y over r, we had y over 1, which is just y. Okay? So now we can do a problem like this. We're going to say if 5, negative 12, pardon me, is, oops, not in, is the point on the terminal side of an angle theta in standard position, find cosine of that angle, right? Now, we know that 5, negative 12 is not on the unit circle. So this is a note. It is not on the unit circle. How do we know that? Well, the unit circle has equation x squared plus y squared equals 1. So if 5, negative 12 was on the unit circle, then the point should satisfy the circle. And 5 squared plus 12 squared, negative 12 squared, is definitely not 1. Okay? So what we have to do is find the radius of the circle. Find the radius of the circle containing 0.5, negative 12. Right? Every point in the coordinate plane is going to be on some circle with a center at the origin and some radius, right? So let's find out which one this is, and as soon as we find out the radius of that, then we can use the definitions above to find the cosine of it. Again, we don't know the angle theta. Doesn't matter. We don't need it. Okay? Alright, so let's take a look at the picture of this. Where's 5, negative 12? Well, here's 5, here's negative 12. It's about right here. Right? So the idea is we're looking for the circle centered at the origin that point lies on, right? And really what we really want to know is the radius here. Yeah. Well, we can use our friend, the Pythagorean theorem, yet again, right? It turns out that I have this right triangle, right, with one side which is 5, the other side which is 12, and my r is what we're going to be looking for. So we know that 5 squared plus 12 squared is equal to r squared. That's the same thing as 25 plus 144 is r squared. That's 169, which is r squared. And r will be 13. Square root of r is positive, but also, the radius is always a positive number. Okay? So, since cosine of some theta is x over r, whatever that radius is, we now have x is 5, right? Remember that I'm getting that from up here. X is 5, and r is 13, I'm getting there. Yeah? So that's the value of cosine of that angle.